So we're going to start with on 2.7 by looking at and comparing different items to see which one is the lowest cost per ounce. So we're going to look at probably just do one of these. They're pretty simple to see, but we're going to look at question 24 on page 164. We're going to look here at question 24. And what we want is we want to find the best buy. And we want the unit price to the nearest thousand. So we want to find the unit price to the nearest thousandth, and we want the best buy. So we want to find the best buy of these, and we want to find the unit price to the nearest thousandth. So what we've got is we've got different salad dressing containers, and we want to find which one is cheapest per ounce. And so we've got the size, which these are all in ounces. And then we've got the cost as well, or the price. So these cost $169 for the 8 ounce, $197 for the 16, and $5.99 for the larger container. And this is going to be size and the price. Now what we want is we want to find the ratio of price per ounce. So that's what we want. We want to find price over the ounce of each one. So that's what we're going to be trying to find. Price over the ounce, or price over the size, whatever it might be. Price per gallon, price per liter if you're looking at different sodas, maybe whatever it might be, but you want the price divided by the ounces in this case, or the size. And you want to figure out which one's the better buy. So I'm going to go ahead and label these 1, 2, and 3. And we're going to figure out which one of these salad dressings is going to be the better buy. So there's 3 different sizes of salad dressings, and they're all different prices. And sometimes it might be that the smaller container is cheaper per ounce because it's on sale. Normally the larger one is the better buy, but not always, because maybe you go to Dillon's and maybe the smaller size is on sale but the larger one isn't. Most places that you go now, most big supermarkets, have that already filled out at the bottom. When you look at the price, something has price per ounce. That little yellow box, if you go to Walmart, Dillon's is the same way. Not all places have that. 20 years ago, that wasn't there. That's just kind of a new consumer thing. But we can still figure out, just by giving the size and the price, which one's going to be the better buy. So let's look at the first one. Okay, let's see what it is. And we want the price the nearest thousand. And that's going to be 3 places. Okay, so thousandth is 3 places. So on the first one, we take our price, which is $1.69. We're going to divide that by 8. And then we round this out to 3 places. And this is going to be now 0.211, and that's dollars per ounce. And so that's the cost of the first one. So the first one's about 21 cents an ounce. The second one. On the second one, what do we have? Well, our price is $1.97. And we're going to divide that by our 16. $1.97, divide that by our 16. And that gives us 0.1 if we round to 3. And that again is per ounce. So this one's better so far because it's 12 cents an ounce. And then the third one, we need to calculate it out as well. And it's $5.99 over the 32. And $5.99, divide that by your 32. Gives you 0.187 if we round. And that's going to be price per ounce. And we want the better buy. So we want the smaller one. And which one's going to be the cheapest per ounce? The 16 ounce. So the 16 ounce jar is the better buy. So is everyone okay with how we did that? All we do is we just take the price, divide it by the size, you look at them all, and you find the one that is the smallest. The one that's the smallest is going to be your better buy. So this one, the 8 ounce, it's 21 cents an ounce for that salad dressing. The 16 ounce jar, 12 cents an ounce, which that's a really good buy. And then the 32 ounce jar, well, it's almost 19 cents an ounce. So the best buy would be the middle one. Maybe the middle one's on sale. And so that's why it's the cheapest per ounce. But when you go to Dillon's or Walmart, you'll always see the tags, and you always have in yellow or some different color what the price per ounce is, and you always want the smaller one. And how do you find that price per ounce, or price per gallon, or price per unit? You take the price and you divide it by the size. So you're going to encounter a couple of questions like that. You find the one that's the best buy. You're also going to encounter some questions where we have to see if these are equivalent, if it's true or false, if these are the same. So are these going to be the same? We need to see if these fractions are the same. And we're going to look at question 31. And this is on page 165. But we need to see if these fractions are equivalent, if they're the same. Okay, true, false. So we're going to look at question 31. We need to see if these fractions are the same. Is 5/35 going to reduce down to the same as 8/56? Well, how do we decide if they are the same? If these are equal to each other, if the fractions are the same, then you should be able to cross multiply. And they should equal each other. So let's see if this is true or not. So that means when I cross multiply, I've got 5 times 56 equals 8 times 35. And let's see if these are the same. We're trying to see if these fractions are equivalent to each other. So we've got 56 times 5. Well, that's 280. The other side, we've got 8 times 35. And that's also 280. So these are the same. So this would be true. These are equivalent. So the answer for that one would be true. They are equivalent to each other. If they were different numbers, they would not be, like 34. So 34 is going to be false. On question 34, we've got a fraction equaling another fraction, and we need to see if these are equivalent to each other, if these fractions are the same. And the easiest way to check to see if they are equivalent, if they're the same, is just simply cross multiply. So go ahead and cross multiply here. And if I cross multiply, I get 27 times 110. It should be the same as 18 times 160. And that gave you 2970 on the left. But on the right-hand side, see, we got 2800. 2,880 is what we got on the right. And these are not the same. So this would be false. So we're just checking to see if these fractions are equivalent. They're the same. And sometimes that might be useful. If you want to say, hey, are these fractions the same? You can just cross multiply and see real quick. And this leads us into other techniques as well. We're going to learn how to solve using cross multiplication. And this is a technique that we're going to be using when we have a fraction equaling another fraction. So let's look at question 42. And these are actually very easy to solve. And the directions are going to be solved for x. So we want to find our x here. So we're going to be solving this for x. So I want to go ahead and solve this for the variable x. And we want to do this by clearing out the fractions. Now, whenever you have a fraction equaling another fraction, so both sides are fractions, then we can cross multiply. So we can clear the fractions by cross multiplying. Okay, so this works when you have a fraction equaling another fraction. Cross multiplying, you get 32x. Oh, did I write it wrong? Let's see. Yep, over 30. Sorry about that. Thank you. Yep, I just wrote it wrong there. That wouldn't have worked very well, so that should be 30 there. Okay. Make sure I wrote it right. Yep, 30. Okay. So that gives you now 30x here. And then on the other side, we've got 4 times 12. And now we'll go ahead and break that down. So we got 4 times your 12, which that's going to be what? 36, I believe. Nope, 48, my mistake. I was thinking of 3. So 4 would be 48 there. So we've got 30x equals 48. Right, cross multiply. We can divide by our 30. And we've got x equals now 48 over 30. Can we reduce that down a bit? I think we might be able to. Okay, because 48 and 30, they both are even numbers, so I know at least a 2. Let's see if 4 will go into both of them. 4 does not, but 2 will. So we can take both of these and reduce them down by 2. So that's going to reduce down to be 24 over 15, right? And I think we might be able to go a little bit further, because you've got to reduce them down. 24 and 15. Let's see, do they have 3's in common? Yep, they do. So I can reduce it down by a factor of 3. And that's going to be now 8 over 5. And that's as far as it can go. So your final answer would be x equals 8 over 5. You need to make sure that you reduce down your answers. And so how did I reduce it down? I started with this 48 over 30. And I said, okay, these are both even numbers. So I know at least a 2 is going to go in there, right? They're both even. So I divided them both by 2. And I got 24 and 15. Well, I know that 15 has a 3 in it. And 24 also has a 3 in it. So let's divide them both by 3. And that left me then with 8/5. Okay, and 8/5 is not going to go any further, because 8 and 5 are both prime numbers. So that's how you would work out question 42. Let's move on to a little bit more complicated ones. Let's look now at question 46. So this one just has a couple of extra steps, but it's almost exactly the same. Question 46, we've got m divided by 5, or over 5, equals m minus 2 over 2. Same concept. Fraction equaling another fraction. cross multiply. So when you cross multiply, you get 2m on the left. Okay, so those go together. Now on the right, you've got to be careful, because on the right you've got 5 and you have to multiply it with parentheses times that m minus 2. So make sure when you do that you put your parentheses around the m minus 2. Now you can go ahead and distribute that 5 through and solve this out. So distribute your 5 through, and that gives you now 5 times m, that's 5m. 5 times a negative 2, that's a negative 10. And we solve it exactly like we solved all of the others. So we're going to move that 5m over. And that leaves you with 3m equals negative 10. And now what do we need to do? Well, now we need to go ahead and solve it for the m. So we're going to divide it by a negative 3. And watch your signs. What happens when you have a negative divided by a negative? Positive. So that's going to come out to be 10 thirds, or 10 over 3. Let's do one more of these, and then we'll talk about setting up these applications. So one more of these. Question, how about 52? So question 52, you've got 3m minus 2 over 5 equals 4 minus m over 3. Again, same procedure. You want to go ahead and cross multiply. Now, when we cross multiply, we're going to have to make sure that we use the parentheses. So we're going to go ahead and cross multiply. So that's going to be 3 times 3m minus 2. And that's going to equal 5 times 4 minus m. I'll slow down a bit so I'm not going too fast here. But you see what we're doing. Okay, we're just cross multiplying. Just form an x. And use parentheses if you need to. Now we can finish it. And we've done a lot of these. So we distribute through the 3 and the 5. And 3 times 3m makes it 9m. 3 times a negative 2, well, that makes that a negative 6. Bring down our equal sign. 5 times 4, that makes it 20, minus 5m. Okay, so that's what we've got there. Now what do we want to do? Solve it for m. So we're going to move that 5m over, like we've done many, many times before. So that leaves you now with 14m minus 6 equals 20. We're going to add our 6 to each side. And now we've got 14m equals 26 there. Divide by your 14. So now we've got m equals 26 over 14. But we're not done yet, because what do we know about that 26 over 14? Well, 26 and 14 are even numbers. So we know at least a 2 is going to go in there. So let's try to divide these both by 2. So 26 divided by 2 would be 13, and 14 divided by 2 would be 7. And now I know to stop, because 14, or not 14, 13 and 7 are prime numbers, so they cannot go any further. So that's going to be your answer there. So always try to reduce it down. If you've got an even and an even on the top and the bottom, try an even number. Try 2 or 4, maybe 6, but reduce it down to get the correct answer for each one of these. And then always make sure you can't go any further. This is done because 13 and 7 are prime numbers. So they won't reduce down anymore. The next ones that we're going to be looking at are going to be setting up a ratio. And these are not really difficult at all to do. It's just making sure that we set up the ratio. Actually, these are probably the simplest applications that we've done in a while. So we're going to look at 55. And once we set up the ratio, these are very, very easy to do. If 6 candy bars cost me $20, then how much would I have to pay for 24 candy bars? Well, we're going to set up a ratio. It does not matter which one goes on the top or which one goes on the bottom. But we've got to make sure we have a ratio. I'm just going to go ahead and put the cost on the top and the candy bars on the bottom. So the cost is going to go on the top and the candy bars are going to go on the bottom. So what do I know? Well, on our first one, I know that 16 candy bars costed me $20. So $20 got me 16 candy bars. This is cost, and this is the candy bars. I want to buy 24 candy bars. So that means my 24 is going to go down here because I want to buy 24 candy bars, and I don't know the price of the 24 candy bars, so it's going to go on the top. But see, these are ratios. And however you decide to set up the ratio, just make sure you do both of them the same. So I chose to put the cost on the top, the number of candy bars that I get for that price on the bottom. So if I spend $20, I get 16 candy bars. I want to purchase 24 candy bars. So that goes here. What we don't know is the price of those 24 candy bars. So that's why the X is going on the top here. Now we simply cross multiply. So let's go ahead and cross multiply here. When we cross multiply, we get 16x equals, and we've got 20 times your 24, that's 480. We're going to divide by our 16. And when we do that, we've got 480. Divide that by your 16. That gives you 30. And so what does that tell me then? That tells me $30 buys 24 candy bars. The answer is going to be that $30. Okay, but that $30, that's going to buy you 24 candy bars. So we set up a ratio. We simply cross multiply. And that was it. 61. Very, very similar. This one's working with the cost of gasoline. We're going to set up a ratio again and solve that ratio. If 6 gallons of premium unleaded gasoline costs $22.56. How much would it cost to completely fill a 15-gallon tank? So again, we're going to set up our ratio. It doesn't matter if you put the gallons on the top or the price on the top. Just make sure you're consistent. That way both sides are the same. I always like to do the cost on the top because that's how we figure out the better buy. And I think it's something you need to remember. So it's always cost and the other number goes down below. So in this case, when we look at the gasoline, we've got cost and gallons. So let's now go ahead and set up our ratio. So 6 gallons of premium gasoline. 6 gallons going to go down here. And that's 6 gallons of gasoline. That costs $22.56. I want to fill up my tank. And my tank holds 15 gallons. And I don't know how much that's going to cost. So I'm going to put the X right there. Because that's the unknown cost. Is everyone okay with how we did that? Set up a ratio, solve it. We now just simply cross multiply. And that gives me 6x when we cross multiply here. On the other side, we've got that 22.56. We're going to multiply that by our 15. And that's 338.4. Divide by our 6. And that leaves me then with my price. And that comes out to be 56.4. And so what does that tell me? That tells me 15 gallons costs $56.40. And the $56.40, that's what you want. So if I wanted to go ahead and fill up my entire car, it holds 15 gallons, I would expect to pay $56.40 for that gasoline. Okay, and that was question 61. Now we're going to look at some more of these. They're all different, but what we do is we set up a ratio for each of these. You can set up the ratio however you want. Just make sure that you're consistent. Let's look at 63. Now, what we're looking at here is we're going to get some fish, collect some fish, and we're going to tag these fish. And then we're going to release the fish. And then we're going to catch some fish, and we're going to see how many of them have been tagged. And this is going to tell us approximately how many fish are in this lake or this pond or even this ocean. So this is how they do it. They get some fish, they tag the fish, they release the fish. Then you go out and have people go out and collect the fish again. Some of them are tagged, some of them are not. But the number of tagged, you can then tell approximately how many fish are in that body of water. So a biologist tagged 500 fish from the northern bay. So they got 500 fish, and they tagged them. At a later date, they found 7 tagged fish in a sample of 700. Estimate the total number of fish in North Bay to the nearest 100. So we want to figure out approximately how many fish we should have in this lake, or bay in this case. So we need to set up a ratio. And what we're going to look at is we're going to look at the number of fish caught and how many are tagged. So we'll look at fish that we got over the tag. And we're going to use this ratio now to see how many fish could be in this lake. So a biologist tagged 500 fish in the Northern Bay. Now, do we know how many fish are total in this bay? No, so X is going to go here. So we got 500 fish and we tagged them. And we released them into the lake or the bay. Now, I don't know how many total fish are in this bay, but we're going to try to estimate it. So 500 fish in this body of water have been tagged. And then I go out and I catch some fish. So I catch 700 fish. And of those 700 fish that I catch, oh wait, let me get it in the right place. 700 should go up here. Sorry about that. So 700 fish that I catch here. How many of those 700 are tagged? 7. Okay, so make sure you get the ratio right. So this is going to be the number of fish that I catch over the number that are tagged. So we don't know how many fish are in this bay, but we know there are 500 tagged. Then we went and we sent people out and they caught 700 fish. And we took the 700 fish and we checked each one of them. And we found that 7 of them were tagged. Now this should give us kind of an estimate of how many fish we think are in this bay. So this is how they do it. If they want to figure out, okay, how many of this type of species there are, they catch some, they tag them, they release them, then they catch some more later and they see how many of them were tagged. And that gives you an idea of how many total there are. So now we cross multiply. And that gives you 7x. And we multiply here. We've got 700 times that 500. That's 350,000. We divide by our 7. And this should give us approximately how many fish are in this body of water here. And it should come out to be about 50,000 fish. So we would estimate that there's going to be about 50,000 fish in the Northern Bay. And that's how they do it. It's kind of a neat thing, but this is how biologists go out and figure out, okay, how many fish are in this lake? How many fish are in this pond? Well, they tag some of them and release them. Then they go back and they have someone go out and catch some more fish, and they just see how many of those fish have been tagged. And that gives you a rough idea of the total population. I mean, it's not completely 100% accurate, but it's really close. That's setting up that ratio to figure out what you wanted here. We can also use the same concept when we look at the lengths of distances on a map. So 67 is a map problem. And we're going to set up a ratio. Same concept. These are all ratios. As long as you set up the ratio, you'll be able to solve it pretty easily. So the distance between Kansas City and Denver is 600 miles. On a certain wall map, this is represented by 2.4 feet. On the map, how many feet would there be between Memphis and Philadelphia? And the two cities are 1,000 miles apart. And sometimes it might be helpful to label each piece so we don't get confused. Now we're going to set up a ratio, and we're looking at feet and miles. Doesn't matter which one goes where. Just set up your ratio and make sure you follow it on both sides. So let's do feet over miles. And we're going to first look at KC to Denver. So the first one's going to be Kansas City to Denver. And Kansas City to Denver, that's going to be 600 miles. So we'll put the 600 there. Okay, so KC to Denver, 600 miles. So that goes there. Now on that map says that is 2.4 feet. Okay, so we labeled it. Sometimes it's helpful to label so we don't get it all mixed up. But this is what we've got. We've got Kansas City to Denver. Feet, miles. We're going to look now at Memphis to Philly. So Memphis to Philadelphia. So Memphis to Philadelphia. And when we talk about Memphis to Philadelphia, this is represented by an unknown amount of feet. So it doesn't tell us how many feet on the map. So that's the unknown. But we do know that Memphis to Philadelphia is going to be 1,000 miles. So that 1,000 miles is going to go down below. Everyone okay with how I set up the ratio? However you want to pick it, doesn't matter. You could have put miles on the top and feet down below. As long as you're consistent, that's all that matters. So you set your ratio, and then sometimes it's going to be easier to label. Now we've got it. We can easily solve it. We cross multiply, and we're done. So cross multiplying, we get 600x. And that equals, when we multiply here, 2,400, I believe, because 2.4 times that 1,000. Yep, that's going to be 2,400. Divide by your 600. And that gives you then 4, isn't it? So what does that tell me? That tells me on that map, that distance from Memphis to Philadelphia is going to be what? 4 feet. So on that map on the wall, it should be 4 feet. And we just set up the ratio and solved it out. So let's look at another one. Let's look now at mixing chemicals together. Let's look at, how about 74? So we're going to have to make up our own cleaning solution here. And we've got to make sure we get the right concentration. We don't want to have too much or not enough. So 74. The directions for the bottle of Armstrong Concentrated Floor Cleaner specify that for extra cleaning strength, a half a cup of cleaner should be used for each gallon of water. How much cleaner should be mixed with 5.5 gallons of water for that extra strength cleaning? So we want to go ahead and make 15.5 gallons. We're going to, again, set up the ratio. And what do we have? Well, we've got cups and gallons, right? Because we've got cups of cleaning solution, mix it with gallons of water. And this is 74. And we'll set this up. Doesn't matter which one goes on top. You just have to be consistent. Let's put the cups on top. So the cups over the number of gallons. So what are we going to start with from the directions? Okay, the directions state this. The directions tell us that we need, let's see, which one was on that? Yeah, I think I read through 73, not 74. So we'll do, well, let's see, which one to do. Now, I think we did 74. Yeah, we'll just do 74. So we want to look at this. We've got cups and gallons of water. And so the concentrated floor cleaner specifies that for that extra strength cleaning, we need a half a cup of cleaner for a gallon of water. So we need a half a cup of cleaner, 1 gallon of water. That's our ratio. We'll put the cups on the top, gallons on below. Now this is what we want to make. So this is going to be our solution. The solution that we're going to make up. We don't know how many cups of that solution that we need, but how many gallons are we going to have to use? Well, we want 15.5 gallons of water, right? Does everyone see how I got the ratio? So this is what the directions say, and this is going to be our new solution that we're going to mix up. Okay, we've got to put this in a floor machine. We want to make sure we fill that floor machine up with the correct strength. We don't want to just guess, because then it might be either too strong and you're wasting chemicals, or not strong enough and it won't work. So we've got to set up the correct ratio. Now I picked this one because we're going to have to remember how to work with fractions as well. We're going to go ahead and cross multiply. And that's going to be 15.5 times a half, and that equals x. Now, how do we multiply these together? Well, we can either use a decimal, which normally we don't want to do, or we can convert these. So if we want to convert these, I'm going to take that 15.5, and I'm going to convert that to an improper fraction. So 15 times 2, that's 30, plus 1 makes it 31 over 2. So that's going to be now 31 over 2. We're going to multiply that by a half. So whenever we work with fractions and we multiply them, we have to make them improper. So I took that 15.5, and that made it 31 over 2. Now we can go ahead and multiply, and that gives us 31 over 4. But 31 over 4, well, that's not going to be very easy to measure out, because if I'm measuring this out, I have no idea what that is. So now let's turn this back into a mixed fraction so that we can then figure out how much I really need to add. So let's go ahead and convert this back. Easiest way to do it is figure out your whole part. So 31 divided by 4. Well, 31 divided by 4 is 7. That's 7.75. Okay, so that means we need 7 and 3/4, because that 0.75, remember that's 3/4. So we need 7 and 3/4 of a cup, of cups of that cleaner fluid. Okay, and how did I do that? Well, okay, I divided. I can definitely smell whatever they're working on there. 31 divided by 4 is 7.75. So remember, that's your whole part. 7 times your 4, well, 7 times that 4 is 28. And 31 minus 28 makes it then what? 3. So that's where that came from. Or you can just remember that 0.75, that's 3/4, either one. That's just a common one, so you can also remember it that way. So we would need then 7 and 3/4 cups of cleaning fluid. So if we were going to fill our machine up, we would go ahead and add in your 15.5 gallons of water, and then we would pour in 7 and 3/4 cups of cleaning fluid. We can also use this to set up ratios. Not used so much anymore, because in modern day technology, this is done automatically. But it wasn't that long ago where if you wanted to enlarge a photo, it had to be done by hand. And we've worked with images and things before, and we know if we drag it, it doesn't look the same, right? If you don't drag it right, then it looks distorted. So I want to make sure that these are not distorted. So we're going to look at 81. So we're going to go ahead now and look at question 81, and we want to find the missing components. So we want to upsize this triangle. And we're going to have to set up a ratio. So we want to enlarge this triangle to this size. Now I need to make sure everything stays the same and proportionate, otherwise the triangle won't look right anymore. So we're going to have to set up a ratio for each one, and we're going to have to find the missing parts. So I'm going to go ahead now and set up my two triangles. And we want to make sure that the size stays the same, the proportion, so they look the same. Because if you just start dragging on an image and you're not careful, it'll all be distorted. And we want to make sure that it keeps the same proportions. Y and X here. And this is going to be 1, so we'll call this one 1, and this one is going to be triangle 2. So I like to label them so I know what I'm looking at. And we're going to set up a ratio as triangle 1 over triangle 2. Triangle 1 over triangle 2. We need to figure out the missing pieces. Now we can only do one of these variables at a time. And we need to figure out how they go together. So let's try to find that x. So what do we know? Well, we know that x goes with that 15. So on triangle 1, we've got our 15. And on triangle 2, the side that matches with it is x. Now we can only do one variable at a time. So we can't do the y at the same time. We have to do it in pieces. So we need another ratio. So let's look at 8 and 12. 8 and 12 go together. So 8 is on triangle 1. 12 is on triangle 2. Triangle 1, triangle 2. 15, triangle 1 goes with x. 8, triangle 1 goes with 12. Now we can solve it. Cross multiply, and that's going to give us one of the pieces. So go ahead and cross multiply here. That leaves me with 8x equals 15 times 12, and that's 180. We'll divide that by our 8. 180 divided by the 8. And that comes out to be, we can use decimals here, that's fine. That comes out to be 22.5. Because if we were using a computer, we would want the decimals. So we can use decimals. Pretty easy to work with, so that's the x part. Now how do we get the y part? Okay, this is for x. Well, if I want to find it for y, I need to make sure the y's match up. The y's match up. If I want to solve it for y, how do they work? Well, triangle 1 has 17. Triangle 2 has the y. Those go together, right? And then what's our other ratio? 8 over 12. Is everyone okay with how I'm setting up these ratios? Right? You just pick your triangles, 1 and 2. Now you want to do them one piece at a time because you can only have one missing part. So when I did my first ratio, 15 went with x, so that gave you that one. 8 went with 12. To get the y, I know that 17 goes with the y. 8 goes with 12 again. So cross multiplying, we get 8y equals 204. We'll divide by our 8, and that leaves us then with y equaling 25.5. So we have now found the missing pieces. So we found the x part, and we found the y part. So if we were enlarging a photo, we would do the x and the y part, plug those numbers in, and that would give us the same ratio. We'd be able to keep the exact same triangle. So let's do one of these consumer price index problems, and then that'll be it for today, I think. So let's do one of these consumer price index problems. If we have time, we might do two of them, but at least one of them. There's a question just like this in your homework. Now, the consumer price index, what this does is this is going to allow you to adjust the price for inflation. So like you can take what you paid for an item in 1980 and you can figure out how much that item would cost in today's money. Because we have inflation, so things are always going up. And it doesn't go up the same rate every year, but you can use this table to calculate approximately how much that item should cost at different years. And what you got is you got the year and you got the index, and that's going to be our ratio. The price that we paid in that year divided by the index of that year. And that's going to allow us to figure out what different things cost at different times. So we'll have enough time. I think we could probably do two of these. So we'll look at 85. So question 85. And we're going to have to use this table to work out this question. And we want to set up this ratio. We want to set it up as price over the index. That way it's consistent with the textbook. So price over the index. And what we're going to do is we're going to convert a price from one year to another. So we're going to use the consumer price index figures in the table to find the amount that would be charged for using the same amount of electricity that cost $225 in 2003. We want to find out what my bill should be in 2005 with inflation. So we're going to use this table. We're going to use that index to find out what our value of that electric bill should be in 2005. So this is what we've got to start with. We're going to start with 2003. And we want to end with that price in 2005. So what do we know? Well, how much did that electric bill cost in 2003? In 2003, my electric bill ran $225. Now we go up to our table. And we find from our table our index. And what's our consumer price index for 2003? Our consumer price index is 184. So we'll put the 184 with the index here. What about 2005? We do not know how much that electricity should cost in 2005. So we'll use an X. But in 2005, what's my index? If I go to my table, my index is 195.3. 195.3 here. This is going to set up our ratio. We'll be able to find out the price of that electric bill, and we're going to round it, it says, to the nearest dollar. So we're going to get this to the nearest dollar. So we cross multiply, and that gives us 184x. We'll use our calculator for the other side. 225 times 195.3 gives you this, 43942.5. We'll divide both sides by that 184. And then we're going to round to the nearest dollar. And rounding to the nearest dollar, $239. And I rounded to the nearest dollar there. So that tells me in 2005, I should pay $239 for the same amount of electricity that cost me $225 in 2003. So it went up a little bit. Maybe we've got a little bit of time left. We're going to do one more. Let's look at 88. So question 88. We're going to start again with 2003. And we want to end up with our cost in 2015. And price over index is what we do for our ratio. Price over index. So in 2003, electric bill was $225. Cost index was 184. 2015, unknown amount of price of that new electric bill. But when we look up our index, it's 237. That's our index in 2015. Now we simply cross multiply, divide, and we are done. So cross multiplying, that's 184x equals now we multiply, looks like 53,325. Divide by that 184. And to the nearest dollar, my electric bill is going to be about $290. So that should be how much that electric bill should cost in 2015. And there are all kinds of different tables for almost every item. The government keeps track of all the items and the average prices of those things, so you could look up the price of a car. So if you know what you paid for that car in let's say 74, and you wanted to see, well, what would a similar car cost today? There's an index for that. You look it up, use the same procedure, whatever the car costed you, divided by the index of that, let's say 1974. You could then figure out, okay, I want to buy it in today's money, so 2021. You put its index in, unknown value, cross multiply, and that'll tell you how much that car should cost in today's money. And again, there's cost indexes for almost everything, because every item's a little bit different. And there's a general one too, but you can look it up on the government websites if you ever want to do that. What's our homework? Well, our homework for today is 2.6. You should be able to do them all. And 2.7. You should be able to do them all. So 2.6 and 2.7. Next week, we're going to go over any questions that you might have from your homework. 2.6 and 2.7 is going to be your homework. And we're looking at our next exam in a couple of weeks, because next week we're going to go over 2.8, and that's going to take a bit, because 2.8's a difficult section. That's probably the hardest one, is 2.8. And then 2-9 is going to be a little bit easier. So next week, I imagine we'll just go through 2-8. And then that following week, we'll do 2-9 and review for our exam. So our exam will be in about 3 weeks, it looks like. And I don't want to rush through these applications because we have to know how to solve them for the next course. So that's going to be your homework. So I'm going to see everyone next week. And I think everyone's turned in their homework, so I've got everything graded in Canvas. Yeah, everybody's turned everything in. So.